Hello everyone. So today we will be covering the learning outcome 4 for introduction to statistics. Just see how many participants we have. We have Jack. So Jack, are you able to hear me?
Yes, I can hear you.
Okay. So we will start the session. So today we will be covering the use of sampling in statistics. So these are the indicative content for today's session. So we'll be studying the terminology and concepts related to sampling, the different sampling techniques which are like probability and non-probability sampling. Then we will go through the explanation of each sampling technique and the uses of each sampling technique, and we will try to understand the suitable techniques in sampling and use of random sample tables and generators. So the first of all, we go through the key terminologies, which is to understand the use of sampling in statistics. So sampling in statistics is basically the technique in which a small group of units is taken to make inferences about the larger population. So for example, if you have to conduct a study on the entire population, it may not be practically viable. So what is generally done is a smaller group is selected so that the findings can be projected to the larger population. So sampling is used in various fields, whether it is academics, whether it is economics, or whether it is quality control, or whether it is marketing. So in statistics, sampling helps in enabling researchers to draw meaningful conclusions and make informed decisions while minimizing the resources needed for data collection. So it provides an effective and efficient way for drawing meaningful conclusions about the entire population. That's why it finds use in academic, scientific, and practical domains to gain insights into various phenomena. So some of the key things about sampling that we need to know, first of all, is the definition of sampling. So a sample in statistics is a selected subset of a population, which is a small representative group from the entire population. So it is chosen to represent the population characteristics accurately. So the purpose of sampling is to save time and resources. So, like I said, it is not possible to collect data from the entire population. That's why the sampling technique is used. So, it provides a cost-effective way to gather and analyze information. In sampling methods, there are various sampling methods which exist, including random sampling, stratified sampling, and cluster sampling. So the choice of the method, it generally depends on the researcher objectives and the characteristics of the population. So another key concept is the theoretical framework. So sampling is grounded in statistical theories such as the central limit theorem, which states that the distribution of sample means approximation of a normal distribution. So it underpins the validity of many statistical analysis based on samples. For example, in a political polling, a sample of registered voters is surveyed to make predictions about the entire voting population preferences. Similarly, in manufacturing quality control, a sample of products is tested to ensure that the quality of the entire production batch to basically assess the quality of the entire production batch. So now we move into the various learning outcomes. So first of all is explain the concept and the different sampling techniques. So like we had gone through the basic concept of sampling, which is to select a small group of participants, which is representative of the larger population. So when we define, it can be said that sampling is a fundamental concept in statistics and research that involves selecting a subset from a larger population of drawing conclusions or making inferences from about the entire population. So this is a rather detailed explanation. The key idea here is that since we cannot go and reach out to the entire population, we have to work with a small representative sample. So what now we look into the concept of sampling and different sampling techniques. So the first main concept in sampling is the population, of course. So the population is the entire group of participants. For example, if you want to collect a sample from a country such as UK, population which is greater than 18 years of age. So it will comprise everyone who is more than 18 years of age. So it represents the larger group to which the research findings will be generalized. So then the next concept is sample. So sample is a subset of the population which is carefully selected to represent the characteristics and attributes of the larger population. So the basic idea is to avoid the bias in the sample so that the sample is uniform and is a representative of the population. So when you extrapolate the sample, you will get the population. So that is the whole concept of sampling is. So the next one is inference. So by studying the sample, researchers can make statistical inferences or draw conclusions about the population as a whole. So that is the whole purpose of sampling. So that inferences can be drawn and the results on the sample can be projected to the larger population. So these inferences are based on the assumption that the sample accurately represents the population. So this again calls for a clear selection of the sample, or basically an accurate selection of the sample so that generalization can be drawn based on the results on the sample. So now we look into the different sampling techniques. So the first one is simple random sampling. Simple random sampling is basically you select anyone at random in the population. So in this, each member of the population has an equal chance of being selected in the sample. So this is typically achieved by using random number generators. So for example, if there are 10 people, for example, if there are 2000 people living in a particular county or in a particular state or whatever unit you may call it. So if you go by random sampling, you can select even two people who live close to each other, or two people who live very far to each other. So it is just a random way of selecting the sample. So what is the advantage of simple random sampling? It is that unbiased and straightforward to implement when a complete list of population is available. So basically you have to select randomly. So that is the use, that is the advantage. But the main disadvantage of simple random sampling is that it may be impractical for larger populations and there is no guarantee of complete coverage. So again, collecting data from the entire sample or it may be very difficult or unviable in case of a simple random sampling. Then we have stratified sampling. So in this sampling, the population is divided into mutually exclusive subgroups based on specific characteristics. A random sample is then drawn from each stratum. So basically, subgroups are created and then you draw samples from those subgroups. So the main advantage of this sampling technique is that it ensures the representation of different subgroups and it is useful for populations with diversity. And the limitation of stratified sampling is that it requires prior knowledge of population characteristics and it can be time consuming. So basically, there will be a lot of time and effort involved in grouping the participants and using the stratified sampling technique. So next we look into cluster sampling. So basically cluster sampling, in this, the population is divided into clusters, for example, groups or geographic areas, with a random sample of clusters is selected. So all individuals within the chosen clusters are included in the sample. So basically the cluster can be a division of a geographic division or various groups, for example, gender. So that way it can be done. So it is useful for geographically dispersed populations and efficient when a complete list of individuals is not available. So that is when cluster sampling is useful. But it has the limitation that it may introduce higher sampling errors if clusters are not representative. For example, if you don't collect data from the entire population to form the cluster, uh, the cluster sampling technique may give bias in the selection of the sample. Then we have the convenience sampling. So in convenience sampling, the researchers select individuals who are readily accessible or convenient to study. For example, if you want to conduct a research on university students who do not have work experience, so it will be very convenient for you to collect data from your own university wherever you are studying. So that is the that is an example of convenient sampling. So the main advantage of convenient sampling is that it is quick and inexpensive and it is suitable for exploratory research. And then the disadvantage is that it is likely to introduce bias. For example, if you select only students from your university and you don't select students from other universities, so there is a chance of bias to be introduced into the sample as it may not be representative of the larger population. So that is the limitation of convenience sampling. So the next we have is snowball sampling. So in snowball sampling, this is used when studying hidden or hard to reach populations. For example, people who are living in very remote places. So in this, an initial participant is selected, and that participant helps to recruit others, forming a snowball effect. So again, that same example. For example, if you find out only one person who is living in a very remote locality, then that person will help you to get other people living in the same locality to be recruited in the sample. So the advantage here is it is useful for studying marginalized or minority groups. So that is the advantage of snowball sampling. But the disadvantage is that it is highly dependent on referrals and may not be representative. For example, if uh, uh, if there are more than 4 or 5 remote locations in your country, but if you go to only one remote location and recruit the sample, then the limitation is that it may not be representative and may not yield a random sampling. So that is one of the challenges in snowball sampling. So the next one is purposive sampling or the judgmental sampling. So in purposive sampling, what happens is that researchers intentionally select individuals or cases that meet specific criteria. For example, if your criteria is like people who have more than 5 years of work experience in the telecommunication industry, so that is a very, very specific criteria. So if you want to recruit a sample or collect data from that sample, then you would be using a purposive sampling techniques where you have defined the characteristics of the population. So any person you meet, or if you want to do a random sampling, it may not be applicable for that study. So the researchers intentionally select individuals that meet specific characteristics. So the advantages is that this is useful when studying experts or specific subgroups, and it is efficient for focused research. Whereas the disadvantage is that it is prone to researcher bias and may lack representativeness. So, so again, the limit with respect to the limitation, the researcher may select individuals in the sample whom they know. For example, among friends, relatives, and colleagues. But if the researcher does not reach out to the larger uh, group from where sample can be recruited, so this may lack representativeness. So now we look into how to use the sampling technique. So basically, the choice of sampling technique should be based on the research aims and objectives and the nature of the population that is being studied. For example, researchers may consider the advantages and disadvantages of the different sampling techniques, and they should make informed decisions on which sampling technique is more accurate. So, for example, if you want to conduct a study for regarding the service of any particular restaurant, for example, so you can use a simple random sampling for the people uh, who have been to that restaurant. So again, one limitation is that only people who have had experience, they can be used as a sample. But uh, if you want to uh, identify participants who have tasted a particular menu or particular dessert, then that is a very specific criteria, and for that you need to have a purposive sampling technique. So that is the difference between use of different sampling techniques. So next, how to select the sample using tables or random number generator. So the first one is using random number tables. How do you use it? So random number tables are pre-generated tables of random digits. So what happens is that the researcher can use these tables to select random samples by associating each element in the population with a specific random number. So how do you get to generate random numbers? So first of all, you need to determine the size of sample you want to select. For example, n individuals, for example, 20 individuals from the population. Then assign a unique identifier to each element in the population. So for example, if the population is say like 2000 people and you want to select only 20. So a unique identifier is given to each member of the population. Now, next you locate the random number table. So many statistical textbooks include these tables, or you can find them online. So how do you work about it? First of all, start at a random entry. So begin at any random starting point in the table. This can be achieved by closing your eyes and pointing to the random spot or the last few digits of a personal identifier. So then you read the digits sequentially from the table. For example, it can be the identifier could be the phone number or the birth date, something like that, or the student ID. So then you match each digit with the corresponding element in your population list, and you have to continue till you have selected n random elements. So and then the record selection is done by recording the selecting elements, and these constitute a random sample. So, random number generator is a software or hardware tool that produces random number within a specific range. Even an Microsoft Excel can produce a random number. So, you can use the random number by specifying the range, by defining the range of random numbers that you want to select. For example, if you have a list of 1000 individuals, your range would be 1 to 1000. Then you have to select the sample size. So determine the size of the sample. For example, 20 out of 1000. So that could be your sample size. Then you use the RNG function in software, for example, Excel or any programming languages to generate the random numbers. Here you specify the range and sample size and request the generation of n random numbers. And then you have to match the numbers to the population. So match each randomly generated number to the corresponding element in the population list. So this way, the process should lead to your random sample. Actually, it's not difficult. You can try it on your Excel sheet or on the internet. Also, you will find many random generators ready to use software. So what are the important considerations when using random number generators? You should ensure that random selection method truly produces random and unbiased results. And then always the same method for random sampling is to be used so as to maintain consistency. And if using a random number generator, ensure that it is a reliable and well-tested source of random numbers. So finally, you should be cautious that when using random number tables, to ensure that digit selection is truly random without any patterns or biases. So the next one is to identify suitable sampling techniques and sample size for a specific context. So here we consider an example. So let's look at the case. So here, imagine if you're conducting a study to assess the job satisfaction levels of teachers in a higher education sector in Manchester, UK. So this is your case study scenario. Your goal is to provide insights that can inform improvements in the working conditions and job satisfaction of these educators. So what can be done is that you can use recommended sampling techniques. First of all, is stratified sampling you can use. So let's recollect what is stratified sampling. It is basically you create stratum of individual units of the population, and then you select from each of the strata. So the rationale for selecting stratified sampling is that teachers in higher education may vary based on factors like age, experience, academic discipline, and employment status. So stratified sampling allows you to ensure representation from different subgroups. So you can have different subgroups of age, you can have subgroups of experience, you can have subgroups of academic discipline, and subgroups of employment status or number of years of experience, that way. So that you have the flexibility to to visualize the different factors and the different subgroups. Now the procedure is that you divide the population of higher education teachers into different strata or relevant characteristics. For example, academic discipline. For example, somebody is teaching human resources, somebody is teaching business strategy, somebody is teaching healthcare. So these could be the different subgroups within the population. And then after dividing the population, you randomly select a proportionate sample from each stratum. For example, if you have to select two number from a subgroup of 5 people, so your sample size will be 10. So then you use a random sampling in each of these subgroups. So it is, what is the rationale? So it is challenging to obtain a comprehensive list of all higher education teachers in Manchester. So cluster sampling can also be used. So you can use cluster samplings by selecting specific institutions, which can be clusters, and then sampling teachers from those institutions. So the procedure is that you should randomly select a few higher educational institutions in Manchester and then sample teachers from each selected institution. So what is the recommended sample size? The recommended sample size is to determine the appropriate sample size. You need to consider factors like desired level of confidence, the margin of error, and the variability in job satisfaction. So these are the statistical terms that you should be aware of. What is the level of confidence? It could be 95%, so that results are statistically segment and only 5% can be rejected. And then the margin of error and the variability in the job satisfaction. So we can also go through a general guideline regarding that. So the first thing is confidence level. So confidence level, so typically researchers use a confidence level of 95%, which corresponds to a Z score of approximately 1.96 for a two-tailed test. So that is the, you're free to use 95%, which is the most commonly used confidence level. Then margin of error. So margin of error, that is, determine the margin of error that is acceptable for your study. For example, if you want a margin of error of plus minus 5% for a proportion estimate, you would use 0.05 in your calculations. Then population variability, need to estimate the variability in job satisfaction among teachers. If you have no prior information, you can use a conservative estimate, for example, 0.25, which corresponds to maximum variability, which is 0.5 into 0.5. So next, you can use this value to calculate the required sample size, which is n E2 minus P2 divided into 1 minus P by E2, where n is the required sample size, Z is the Z score for the desired confidence level, P is the estimated proportion of teachers satisfied with their jobs, and E is the margin of error, sorry. So after plugging in these values, you will obtain the minimum sample size required for your study. So that is so that gives you an estimate of how much data you need to collect, or how many sample that you need to have in your study to make it a valid and reliable study. So keep in mind that the larger sample size will provide more precise estimates, but maybe more resource incentives. So this is another consideration that you need to keep in mind. And you should also balance your research objectives with practical considerations when determining your final sample size. So next, we look into to justify the sampling technique and sample size in a specific context. So here, what is that justification of sampling technique? For example, stratified sampling. So the context is the population consists of teachers in the higher education sector in Manchester, UK. So the research aims to provide insights into job satisfaction level among these educators. So should be a problem statement. Then you have rationale for stratified sampling. So population heterogeneity. So teachers in higher education can vary significantly based on factors such as age, work experience, academic discipline, total number of years of experience, and employment status, and which discipline they are teaching. So you need to understand all these subgroups that can be formed, and accordingly the you have to address the population heterogeneity. So these variations may influence their job satisfaction level. For example, if a person has a higher experience but he's not being provided the opportunity as per his potential, and he's teaching only low level subjects, then that can lead to high dissatisfaction with the job. So, and for example, if a person is of mathematics background and he is being forced to teach geography, so that will again lead to higher dissatisfaction with the job. So, you need to have a proper rationale for stratified sampling. Then there is improved representativeness. So, what this means is that stratified sampling allows us to ensure that each subgroup within the population is adequately represented in the sample. So this is essential to capture the diversity of experiences and perspective amongst the teachers. So the next thing is enhanced precision. So by sampling from each strata, we can potentially reduce the sampling error and improve the precision of our estimates within each subgroup. So stratified sampling, it provides higher precision. So this is especially valuable when you want to analyze job satisfaction by different characteristics such as academic discipline. Then we have inference to subgroups. Since the research objectives may involve making comparisons or inferences about specific subgroups, for example, job satisfaction of junior versus senior faculty, stratified sampling provides the necessary data to perform such analysis. So another technique could be like purposive sampling, where you are selecting the teachers who have job experience of say more than X number of years, for example, 10 years. So that is also, that way also you can use the purposive sampling technique. Then this thing, so we are discussing about stratified sampling. So stratified sampling also has the benefit of increased external validity, which means that the findings can be generalized to the larger population of higher education teachers in Manchester. So remember that the study is focused only on the teachers in Manchester. So you cannot go and say the study also applies to the teachers in Liverpool or Blackburn. So that is just an example. So justification of sample size, the desired objectives involve assessing job satisfactions level amongst higher education teachers. Then we aim for a confidence level of 95% and a margin error of plus minus 5%. So then next is sample size calculation. So again, to determine the appropriate sample size, the formula of NZ2 minus P minus 1 minus P divided by E2. So this is the sample size calculation that can be used. So next example will be that a sample of 384 teachers is justified for the following reasons. Number one, the desired confidence level. For example, the sample size calculation ensures that confidence level of approximately 95%, which is a commonly used level in research, and margin of error. The sample size calculation results in a margin of error of plus minus 5%, which provides a reasonable level of precision for assessing job satisfaction levels. And then a sample size of 384 is manageable and practical size for data collection and analysis. So by using the formula for sample size, we get this number of 384 by using say 1000 sample, analyzing the 1000 sample and then using this formula. And then the sample size is likely to provide sufficient statistical power to detect meaningful differences or patterns in job satisfaction levels among subgroups if such analysis are planned. So this is how you arrive at the appropriate sample number. So that is all for today. In case if you have any questions, you can let me know.
That's brilliant. Thank you.
Thank you. Thanks for your time.
Yeah, thank you very much.